Ever wondered how space chemistry revolutionized the clothes you're wearing right now? Get ready for a cosmic connection to your closet. In 1969, scientists made a groundbreaking discovery that would transform the textile industry forever. They found ferrocyanide, a complex iron compound, floating in the vast emptiness of space. This wasn't just any cosmic discovery, it was predicted by theoretical calculations before it was even detected, showcasing the power of scientific prediction. During the Industrial Revolution, textile manufacturers struggled with a persistent problem. Dyes wouldn't stay vibrant on fabrics, leading to faded, lackluster clothing. The discovery of ferrocyanide unique molecular structure in space provided an unexpected solution. Scientists realized this compound's ability to form strong chemical bonds could be applied to dye fixation. By adapting the same complexation mechanism found in interstellar ferrocyanide, researchers developed new methods to lock dyes into fabric fibers. This innovation created more stable, longer-lasting colors that could withstand washing and wear. The breakthrough transformed textile manufacturing, leading to the vivid, durable clothing we take for granted today. What other secrets from space might be hiding in your everyday life? Drop a comment with your guess about which everyday item could have an astronomical connection. Did you know that nuclear testing once disrupted phone calls and radio signals? Scientists uncovered this shocking connection between atomic bombs and communication breakdowns. In 1963, researchers made a startling discovery while investigating mysterious signal interference affecting local telecommunications equipment. They found that nuclear tests had been releasing strontium-90, a radioactive isotope, into the atmosphere at alarming rates. This invisible threat wasn't just dangerous for health reasons. It was creating a chemical chaos in the sky that scrambled our ability to communicate. The strontium-90 particles, dispersed high in the atmosphere, acted like tiny signal scramblers interfering with radio waves and telecommunication signals passing through contaminated air spaces. This revelation sent shockwaves through both the scientific community and telecommunications industry. Local communication networks were particularly vulnerable, experiencing unexplained disruptions that could now be traced back to nearby nuclear testing sites. This discovery transformed our understanding of how nuclear processes affect everyday technology. It led to the development of new safety protocols and monitoring systems to protect communication equipment from radiation-induced interference. Scientists began regularly testing atmospheric strontium-90 levels and establishing safety perimeters around testing sites. What other invisible threats from nuclear testing might be affecting our modern technology? Drop a comment with your theories about how radiation impacts our daily lives. Did you know that a manufacturing mistake led to one of the biggest fuel-saving breakthroughs in automotive history? Scientists were about to throw away a failed batch of carbon nanotubes when something incredible happened. Back in 2004, European researchers were struggling with a persistent problem. Their carbon nanotube samples kept clumping together during production. These tiny tubes, thousands of times thinner than human hair, were meant to reinforce car parts. But the accidental clustering revealed something fascinating. The nanotubes were changing their molecular behavior in ways nobody expected. As oil prices skyrocketed across Europe, this mishap turned into gold. The clustered nanotubes created unique intermolecular forces that, when incorporated to vehicle components, reduced fuel consumption by 10%. That's like getting an extra 3 miles per gallon, all from a manufacturing error. The discovery couldn't have come at a better time, as Europe grappled with severe fuel shortages and rising costs. The modified nanotubes were quickly integrated into automotive parts, making vehicles more fuel-efficient without requiring major design changes. This accidental discovery demonstrated how nanochemistry could revolutionize everyday technology, transforming a production failure into an energy-saving triumph. What other groundbreaking discoveries might be hiding in our failed experiments? Share your thoughts below and explore more amazing chemistry accidents that changed our world. Did you know that concrete became an unexpected hero in one of history's worst nuclear disasters? A deadly radioactive element taught us a life-saving lesson about safety. In 1986, when the Chernobyl reactor exploded, scientists faced a terrifying challenge, containing the spread of radioactive materials across Europe, while tracking the movement of cesium-137, one of the most dangerous radioactive elements released. Engineers made a fascinating discovery. This lethal isotope wasn't behaving as expected. It was actually binding to concrete surfaces in a unique way. The concrete's molecular structure created a natural trap, preventing the radioactive particles from traveling further. This accidental finding revolutionized how we handle nuclear waste across the continent. engineers began developing specialized concrete mixtures designed specifically to capture and contain radioactive materials. The discovery led to new containment facilities that could better protect communities from radiation exposure, with some concrete barriers reducing radioactive spread by up to 90%. These improved methods became standard practice in nuclear facilities throughout Europe, significantly reducing the risk of contamination during both normal operations and emergencies. While this breakthrough helped make nuclear power safer, we're still searching for perfect containment solutions. The question remains, what other surprising materials might hold the key to completely safe nuclear waste storage? Share your thoughts below if you're curious about nuclear science. Did you know the first moon landing relied on batteries similar to those in your remote control? In 1969, NASA made history not just by reaching the moon, but by pioneering revolutionary battery technology that would change space exploration forever. The Apollo 11 mission carried silver-zinc batteries, chosen for their exceptional power-to-weight ratio and reliability in extreme conditions. These batteries worked through a fascinating electrochemical process where electrons flowed between silver and zinc electrodes, creating the perfect power source for space travel. Unlike traditional batteries, these specialized power cells could deliver consistent energy even in the harsh vacuum of space, making them essential for keeping astronauts alive and equipment running. But this groundbreaking technology came with a hidden cost. The same chemical bonds that made these batteries so effective also made them environmentally hazardous when disposed of. Scientists discovered that improper disposal of silver-zinc batteries could release toxic compounds into soil and water systems, creating a lasting environmental impact that we're still dealing with today. As we continue to push the boundaries of space exploration, we face a crucial question. How do we balance our drive for technological advancement with our responsibility to protect Earth's environment? Consider this: what if the next great space discovery comes at the cost of our planet's future? Share your thoughts on how we can make space exploration more sustainable.